Hello, my geometry students. If you can believe it, we've made it to proofs. I know most of you have heard something about proofs. So before we can actually do any proofs, we have to learn like what are the things you're allowed to say in a proof and what does a proof look like, all right? So in your new packet that you just got, the inside page has a quick rundown of what's coming. So today we're going to be talking proof reasons. Then we're going to talk about some things you're allowed to say in proofs. Eventually we'll do what we call our little mini proofs. And then we'll work into triangle proofs. And you can see we have a quiz. We also have a test in this unit, but those are things to talk about at a later date. All right, so this first page where it says intro to proofs says for each proof that we do, there will be a given diagram and also a given set of statements. So you always have to have information to work with. So we say that this is what's given to us, and then you build from there, right? So the goal is to prove whatever is being asked by drawing conclusions from the diagram and the given statements, all right? So it says we organize our proof into a 2-column format with statements on the left, and then reasons are going to go on the right. So statements on the left and reasons on the right. So you'll basically read through it as like, I can say this because, and then whatever follows on the right-hand side, right? So it's saying it allows us to logically show our steps, and these are the accepted steps that you can use. So you can't necessarily just use anything. So that's why we start with these, like, here's the rules. It's almost like playing a game. You have to know what the rules are, all right? So for each of these, we use this little arrow to say like segment bisector. You can write it as implies, or if I have a segment bisector, then here's what I know, all right? So there's a bunch of, not a bunch, but there's 2 ways you can kind of read it. But the idea is here's the vocab word we know. This is what it tells us. So for the first one, a segment bisector tells us that we're cutting a segment in half. So we're going to end up with 2 congruent segments. Now you can write out the full word, or anytime there's a symbol available, you can use the symbol. As for angle bisector, well, it would make sense that you're going to end up with 2 congruent angles because it's going to split an angle in half. So 2 congruent angles. If you are given a midpoint is going to act very similar to a segment bisector. That's going to tell us that we have 2 congruent segments as well. All right, vertical angles. If you have angles across from one another, that means that they are congruent to each other. So you can say 2 congruent angles or just plain old congruent angles would be fine. And we're going to talk in the future, maybe we even want to star this one. That is one of the few steps you can say without it being given to you. So this one does not need to be given. It's just based on the diagram. So I'm going to say not given. It's based on the diagram. All right. Complementary and supplementary angles. We won't use these a ton in proofs, but it's still good vocab to review. So complementary angles means that we have a sum of 90. And then supplementary angles means that we have a sum of 180. And now linear pair. If you have a linear pair, it means they're forming a straight line. So again, that's another thing that would tell you that you have supplementary angles. And then you'd be able to go supplementary means sum of 180. Right? These are super useful. When you have an isosceles triangle, by definition, it means you have 2 congruent sides. You can use the word sides and segments kind of interchangeably here. Whereas once you know the sides are congruent, you also know that the angle's opposite. So the base angles are congruent. So we say it as 2 congruent base angles. And if you want, feel free, this is your notes. You can add a little diagram here. So if here's the 2 congruent sides, then down here would be the 2 congruent base angles because that's literally the base. All right, perpendicular. Instead of leaning towards numbers, so we could say perpendicular means 90 degrees. What I want to focus on is right angles. So if I have perpendicular lines, that forms right angles. And then if I have right angles, plural, right, that means that they're congruent to each other. So it's like saying, all right, if these angles are both 30 degrees, then they have to be equal. Well, in this case, if they're both right angles, they would have to be equal. So we'll be able to use that nicely in our proofs. In the future, we'll talk about when it might be appropriate to say right angles implies right triangles. But for now, right angles implies congruent angles. All right, you got a couple more vocab terms. Parallel lines. This can mean one of many things. Often, parallel lines is going to mean that we have congruent alternate interior angles. And if you can think, that's when you get that Z-shaped form, when it looks like this. But it could be congruent corresponding angles. So I'll put like a little extra arrow there. Or it could even be congruent alternate exterior angles. So multiple things that could happen there, right? As for median and altitude, we talked about how to construct these. A median is the segment that goes from the vertex to the midpoint. So if we're told something is a median, then we know that a certain point is a midpoint of a segment. And then again, if we have an altitude, that's constructed by dropping a perpendicular to a line. That means that we know that we have perpendicular lines. And then you'd be able to follow perpendicular gives me right angles gives me congruent angles, and so on. Right? So a lot of these, it's kind of like connecting the dots. Now on the back, there's a couple more. We're not going to go over all of them this moment, but this sheet is going to be super important. So some other things that we'll see over the next few days are the reflexive property, transitive property, addition postulate, and subtraction postulate. We'll talk later in the unit about CP/CTC, and then we'll come back to this to fill in what tells us that we have an isosceles triangle and so on. All right. So this page is be something that we'll see again later. All right. So the bulk of our notes today are figuring out how to use those reasons and what you would say that would match up with them. Now, because my pages are separate, I'm going to take advantage of that. I'm going to have my sheet right next to me. All right. I'm going to give you another copy of this as well. That's on colored paper that you be able to use and have as a nice like reference page. Right? So this first thing, it says that we have AB bisecting segment CD at E. So when you look at the picture, AB comes through and bisects CD at E. So I want you to circle the vocab term, and in this case, what it's bisecting. So bisects CD. So that means when we come back here, we have a segment bisector, because that's what it's bisecting, is a segment. So I'm going to have two congruent segments. So the second you see the vocab term, that vocab term is going to come right down here into the reason. So you're going to say segment bisector, and then implies two congruent segments. All right. So if that's the reason, then what I have to be saying over here better be talking about two congruent segments. So in the picture, if AB comes through and bisects CD, then CD is getting broken into two congruent parts. So what's going to match that is that segment CE is congruent to segment ED, because a segment bisector gives us two congruent segments. So when you go back and read through it, this should be explaining why you're saying this step over here. All right, the next one, we've got BD bisects angle ABC. All right, so focusing on what we got here, we are bisecting an angle. So down here, that means I'm going to say angle bisector implies what? All right, well, angle bisector implies that we should have two congruent angles. All right, two congruent angles. Awesome. All right, what are my two congruent angles then? So come back to the picture. BD bisects this angle right here. So I end up with these two little guys congruent to each other. So this is angle ABD, congruent to the angle next to it, CBD, because an angle bisector gives us two congruent angles. Awesome. All right. So hopefully you're starting to get the hang of what happens here. So you're searching for that vocab term. So M is the midpoint of AB. All right, in this case, midpoint is what I want to latch on to. I don't have to worry too much about the AB because it's different than the last one. There are two different types of bisectors. Here it was important to note that this was bisecting a segment, this was bisecting an angle. Midpoint is just midpoint, all right? So down here, I can say midpoint implies, and then come back to your sheet, two congruent segments. So let's fill that in over here. And now look to your picture. What are the two congruent segments if M is the midpoint? Well, if that's my midpoint, AM is then congruent to MB. So AM is congruent to MB because midpoint implies two congruent segments. Awesome. All right. Here's the one that we starred. We mentioned that for vertical angles, you would not be given anything. It would just be based on the diagram. So when you see no given in this case, and you see those little X-shaped lines, that means that I've got two congruent angles because they're vertical. So how we would do this is we'll use the ones that are labeled. We'll often just put numbers inside the angle so that we can reference the angle by the number. So I'm going to say that angle 1 is congruent to angle 2. And that is because vertical angles, and you can use the little angle symbol if that makes things easier, implies two congruent angles. So you can use the word, you can use the symbol, as long as it's an appropriate symbol that you're going to know what you're talking about and I'm going to know what you're talking about, then it's perfectly fine to use it. All right. The next ones, we're going to go through these two quick only because they don't get used very often. But the idea that angles 1 and 2 are complementary, and then this next one, 3 or 4, are supplementary. All right. So vocab wise, complementary is what we're latching onto. And so complementary, try to squeeze this in here. Angles implies a sum of 90 degrees. So that's what I need to be talking about over here. So I'm going to say that angle 1 plus angle 2 equals 90. And then we can do the same here for supplementary. So when we have supplementary angles, that implies a sum of 180. So look at the picture. These two together are giving me 180. So I can say that angle 3 plus angle 4 equals 180 degrees. All right. Same thing goes for this next one, saying 3 and 4 are a linear pair. And if they are a linear pair, then that means that they are supplementary. So linear pair implies that they are supplementary. Now, these are all separate examples, but if this was in an actual proof, it would make sense that this would be given to you first, and then we would be able to make that next statement here, all right? So we would want to say that angle 3 and, oops, just realized I wrote that really weird. I can say that angle 3 and angle 4 are supplementary. All right. For the next one, you've got triangle MAD is isosceles with base MD. So anytime we're given information about an isosceles triangle, you know that you have two sides congruent, but you can't assume which two are congruent. So you always have to be told which side is the base. So if MD is the base, that's the side that's not congruent to any of the other ones, which means that what we're going to have here is MA congruent to AD. All right. So what we can say is MA is congruent to segment AD. And now here's where we get to use our vocab, because isosceles implies, or you can write inside isosceles triangle, implies two congruent sides. And now if you wrote two congruent segments, sure, perfectly fine. All right, sides, segments, all the same difference. There was a second thing that went with isosceles, the fact that the base angles are also congruent. So that's why you have another line here. You can now say that the base angles, angle M and angle D, are congruent. And your reason, right off the reason sheet, would be an isosceles triangle. And you can abbreviate that to ISOS if you like. Sometimes isosceles can be tricky to spell. Implies two congruent base angles. All right. So what I expect you to take away from this page is the idea that once I see a vocab term, that goes into the next line right here, and then I follow it with what the reason says. And then that should support something I can say here. So when you go back and reread it, triangle MAD is isosceles, and then MA is congruent to AD because an isosceles triangle means there's two congruent sides. And angle M and angle D are congruent because an isosceles triangle also means that there's two congruent base angles. So you could literally like fill in with some, connecting words there, and the argument should make complete sense. All right, let's move on to the next page here. There's a couple more vocab terms that we want to get out of the way. So we have AB perpendicular to CD. So you can put in the little perpendicular symbol there. Right? These two steps, they're always going to go hand in hand. So perpendicular is the vocab term. So perpendicular lines implies that we have right angles, which means I need to over here say that something is a right angle. Now I can use the letters ADC and BDC, or you can write numbers in the angles and reference the angles that way. So I can say angle 1 and angle 2 are right angles because perpendicular lines imply that they're right angles. Now here's the vocab term. Let's keep rolling with it. Right angles implies that they have to be congruent to each other. And so I can say angle 1 is congruent to angle 2 because right angles have to be congruent to each other. You could literally write the statement, all right angles are congruent, but we like this little implication notation here. All right. For the next one, you have AB is parallel to CD. In the diagram, you can use the arrows to show that. But given the picture that we have, you can see it's a backward Z, but you can see that Z shape popping out. So that means in this case, we're going to use parallel lines to imply that alternate interior angles are congruent. All right, which means in this picture, angles 1 and 2 are congruent. All right, 2 left in our little practice sheet here. We have that AB is a median. All right. Well, it's not drawn in, so let's draw it in. Now, typically it would already be here, but I like this one because we have to think about where should B go. So a median, think about what we said median implies on that last note page. Median implies that we have a midpoint. So that means that A, wherever B is the midpoint of segment MD. So I want you to plot that so that it looks reasonable. Right? So try to plot B so it looks like it's in the middle there. And then if B is the midpoint, that's our new vocab term, midpoint, and you can abbreviate the words if you need to, implies that we should have 2 congruent segments. So MB and BD. So that's what I'm going to put over here. MB is congruent to BD. And now to fully make this make sense, I should finish up the diagram itself. So I have a straight edge sitting here. I can line it up. There would be AB right there. So that's the median. If it was an actual triangle proof, it'd already be drawn in. All right, AB this time is the altitude of triangle MAD. All right, so let's think vocab-wise. Altitude implies what? Anytime you need to, you flip back, you take a look. Altitude gives you perpendicular lines. So if altitude gives me perpendicular lines, that means that AB has to be perpendicular. So you can kind of drop it straight down, perpendicular to MD. And then let's finish the thought here. Perpendicular would then imply what? Well, we just practiced that one. It's at the top of the page. Perpendicular would give you right angles. And so you would be able to say that ABM and ABD are right angles. You could also have said, hey, let's call that angle 1 and angle 2. Sure. All right. And then we could even keep going with this. I'm going to say dot, 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 because we could then say right angles implies congruent angles, right? So there's a lot of ways that you could continue on with this. All right. For time's sake, what I'm thinking is let's do one of these examples. We'll save the other one for class. So this is what a proof would kind of look like, where you are given a couple things here. You're given a diagram. And then you, in a full proof, you would have a proof statement. So you'd know, like, where am I going with this? What am I working towards? All right. So that's why it says in a few days, we'll learn enough to prove triangles that are congruent. So eventually we'll be able to say, like, hey, can we prove that triangle ADC is congruent to triangle BDC? We're just not there yet. So we're just practicing the steps. So how we will start these is to say, all right, I always start a proof with a given. So I would put the first given down and say D is the midpoint of segment AB. And under reasons, we'd write given. All right. Then, just like we just practiced, step 2, we would take that vocab term and see what we could say from it. So midpoint implies 2 congruent segments. All right. Then you'd look to the diagram to figure out what are the 2 segments I want to say. So if D is the midpoint of segment AB, that means that AD and DB are the 2 congruent segments. So that's what goes under the statements, AD and DB. All right. If we then say, okay, well, we've said what we could from that, then we go on to the next given. So the next given is that CD bisects angle ACB. And I know that because it was given to me. And then you'd have to think, okay, what is really given to me right here? Well, they're giving me that CD bisects angle ACB. So if you bisect an angle, that means you're given an angle bisector, which that was way back at the beginning there. And an angle bisector is going to give us 2 congruent angles. So 2 congruent angles is what would go here. And now you have to look at the picture. Sometimes it helps to kind of trace it out. So it's saying CD, this bisects angle ACB. So if I kind of highlight angle ACB, it outlines the angles that we're talking about. So the 2 angles would be angle ACD and then angle BCD. So over here, I could say angle ACD is congruent to angle BCD. All right, we're going to stop at that first one. We'll save the second one for practice in class. Remember, you are joining class every day for this unit, whether you are at your home day or you're an in-person day. All right, don't forget to go answer the post-video question. Thanks, guys.